I am standing in today for Billy Wilkins. Billy and I are the primary developers for NextEra, Nebraska, and Kansas. My name is Matthew Jones, and I have the honor today of introducing Martha Shulski. So Martha Shulski is a professor of applied climate science in the School of Natural Resources at the University of Nebraska in Lincoln. Martha serves as the state climatologist and as director of the Nebraska State Climate Office. Dr. Shulski's work focuses on environmental monitoring through the Nebraska mezzanine, stakeholder engagement, and applied research. She's been faculty at UNL since 2009 and has 20 years of experience in applied climate, taking her from remote Alaska villages to the windswept Nebraska sandhills. She was a co-author on the 2018 U.S. National Climate Assessment and has published a book, 48 journal articles, and you can find her regular column in Weather in Nebraska Land magazine. So please join me in welcoming Martha to the stage.
Thank you very much. I'm going to unmask so I don't suffocate myself here while I'm talking. So I assume this controls my slides? Excellent. Okay. Thank you very much to John Hansen. I really appreciate the invitation to come speak with you today. I'm just going to give a little bit of background about the Nebraska State Climate Office for those of you who are not familiar with us. And I know not all of you are from the state of Nebraska, so pretty much every state in the country does have a state climate office. And we are like a climate help desk or resource office. We deal with all scales of climate, past, present, and future. We deal with the weather scale. A lot of our effort goes into environmental monitoring, and that's below ground and above ground. You see one of our weather stations here. We have a very small staff. We're only about 5 full-time people, so we're a pretty small office. But this is our activities. We center on observing our environment, engaging with stakeholders. I'm located at a university, but I work primarily outside of the university and engage with groups like this. As state climatologist, I give lots of talks on climate and climate change. And ultimately, what we would like to do is help inform decisions. Climate touches everything and all of us, and so information that we provide hopefully informs decision-making. Let's see. Did I skip? Oh, there we go. The Nebraska Mesonet, a lot of state climate offices do have a monitoring program. Where you see a number on that map is where one of our 63 weather stations are. Since we're at a wind and solar conference, I thought I would show an image of solar radiation. This was as of Sunday. So if you're from Nebraska and you're not familiar with the Nebraska Mesonet, I would encourage you to check us out if you're interested in real-time and historical weather conditions. So I'm here to talk about climate change. And I just wanted to start by giving kind of an overview of the impacts of climate change. What are these indicators of climate change that we are experiencing? Large-scale warming, especially in the Arctic. I used to live in the Arctic, and I lived and worked in Alaska, and the rates of change are really significant there. But things are changing pretty dramatically. We see influence on snowpack in the west that is decreasing. There's also an earlier melt in the season, so that springtime snowmelt pulse of water, there's less of it, and it's occurring earlier in the season. More heat waves, heavier precipitation. You can read that list of indicators. These are probably metrics or things that you've felt. This is how we are dealing with climate change. So in terms of energy supply, whoops, wow, gosh, this is touchy. Sorry about that. Energy supply, delivery, and demand. This is information from the U.S. National Climate Assessment that came out in 2018. there is a chapter that is specific to the energy sector, and here are some highlights there. There's a really interesting infographic that you see here. This can be expanded, and it highlights climate change implications for various components of the energy industry, from capture to storage to how it kind of infiltrates our daily lives. But I just wanted to share these basic points here. The nation's energy system is already affected by extreme weather events. Sorry, I don't have a monitor right here that I can look at, so I apologize if I'm turning my head here. Risks to the energy sector will increase due to extreme weather events. The energy system reliability, security, and resilience underpins virtually every sector of the U.S. economy. So just some bullet points here again from the U.S. National Climate Assessment. This is put together by scientists that assess the state of knowledge of climate and implications of climate change. And the web address is down there in the corner, so I would encourage you to visit that chapter specifically online. All right. So Nebraska's climate past. Let's think about where we've been in the state of Nebraska. Kind of these overarching themes to climate change is that we have warmed by about 1.5 degrees. That's about the global average amount of warming. So Nebraska has warmed at about the global average rate, and that is picking up. It is accelerating. We know that nights are warming twice as fast as daytime high temperatures. We see a trend toward wetter conditions and more extreme rainfall events. So these are ways that we are currently feeling climate change. An exception to this, February has cooled recently. The last 30 years have seen about 5 degrees of cooling within Nebraska and the Great Plains. And I'll come back to this later because there was a great example of this past February in 2021. All right. So our climate future is up to us. We can choose this business as usual approach where we do nothing to mitigate future climate change. That's the red curve. Or we can choose this less risky approach. These are called representative concentration pathways. It's based on emissions, so greenhouse gas emissions. So that's what the RCP stands for. So that 8.5 is assuming that we do nothing. That assumes that the global average temperature increases an exceptional amount. That would be a very high-risky approach that's really not sustainable for us. That RCP 4.5, and that number 4.5, that's actually how much extra radiation we would get from the greenhouse gases. Right, the greenhouse effect is a well-known phenomenon in the atmosphere that we've known about for over 100 years. The more greenhouse gases are in the atmosphere, the greater our temperature is here on Earth. So that 4.5, that's what we want to track toward, okay? A much less risky approach. Right. So the Inter-Governmental Panel on Climate Change, they came out with this 6th assessment report just a few months ago. So again, this covers the current state of knowledge, the most recent climate model output, and what it's saying is in 30 years, if we do nothing to mitigate climate change, this is the amount of warming that we will experience. So central Nebraska will look more like southern Kansas in this scenario. Okay, this is the 8.5 RCP. This is the red line in that previous curve. You see a lot of warming in the Arctic. Why is that? That's because the Arctic is covered in sea ice. When it warms, there's more sea ice that melts, more ocean that is uncovered. Ocean absorbs a lot more solar radiation than ice does, so you get an amplification of warming in the Arctic. In terms of that was temperature, let's think about precipitation. So I mentioned that Nebraska has gotten wetter over time. That trend will likely continue in a warmer world. The number that I show on the screen here is about 12%. That's, in general, what we would see an increase in our average annual precipitation. You see some hatchings on this global map, and what does that mean? That means that the climate models there's less confidence in that climate model output where you see the hatching. So you didn't see that very much on the temperature graphic. There's more uncertainty in these precipitation projections. Okay, so when and how we will get our precipitation will continue to change. So I mentioned that we'll get wetter. There will be more heavy rain events, more erosion, more runoff, and less effective precipitation, right? We'll have more rain that occurs in these heavy downpours as opposed to these nice, gentle rain events. We'll also transition to drier during the summer months, June, July, and August, and wetter during the colder time of year, December through about May. We're looking at a wetter than what we experience right now. The image that you see I'm showing here, that is from the flood of March of 2019. It was very large-scale flooding. That was the combination of several different factors. We had a very cold February. We had a wet winter and spring. The soils were saturated and they were frozen. And we had a record snowfall year in Lincoln and other areas. And we had this extreme storm event that came through at the middle of March. That was the trigger that led to this very intensive flooding that we did experience. More extreme events and greater variability. Again, this is a common theme of climate model output, and implication of climate change is greater extremes and greater variability. So going quickly from, say, a dry year to a wet year, from one extreme to another in quick succession, that is also a common theme of climate change. So what do we need to do in order to avoid that red, that RCP 8.5 curve? What do we need to do to stay on that blue curve? Stay within a carbon dioxide global concentration of about 450 parts per million. Right now we're at about 416 parts per million, I believe. So that means that we need mitigative action into place in the very near term. That's what needs to happen. These are all the checkpoints that you see here. This is all from literature, statistics that I pulled from the literature. Decarbonization of the power sector by 2050. In order to achieve that goal of staying within a limit of carbon dioxide amount in the atmosphere, that's what needs to happen. And so there's a lot of room for renewable energy growth. Renewables currently meet about 14% of the global demand. So this most certainly needs to increase. Okay. So I'm a climatologist by training, and so renewables is not my specialty, but I was getting into the weeds of some of the literature, and so that's kind of what this next section covers. Is I'm going to focus on wind and solar and what some of the implications of these climate change projections are for wind and solar. If we focus on solar specifically, the models have actually projected less growth than what has happened. So we're consistently underestimating the growth of solar energy, or we have in the past anyway. The technical potential exceeds projected energy demand and is greater than wind potential on a global scale. This could supply 30 to 50% of electricity in competitive markets. So there are some barriers there, but that's the potential. So I'll show some statistics on wind here. Global extractable resource greatly exceeds present total primary energy supply. In the program for this meeting, there's a map of wind speed in Nebraska, right? There's a lot of wind potential in Nebraska. There's unharvested energy that's going past us all the time. So there's a lot of potential. Wind could supply 10 to 31% of electricity worldwide by 2050. So again, a lot of room for growth. Growth of installed capacity is about 24% annually over the last decade or so. That's a rough statistics that I've seen. All right, so given the climate change projections that I talked mostly about temperature and precipitation. So let's think about if we're installing all these wind turbines out there, if we're ramping up renewables, wind and solar, what sort of implication will climate change have on this industry? So in looking at the literature, one thing that's clear is that global and regional models do not fully reproduce wind climates. So I mentioned the issue with precipitation and low agreement in the models. Wind is even more difficult to forecast or to predict on a decadal level, right? Wind is something that's highly variable from day to day, season to season. So it's difficult to capture that overall in a global climate model. What we can capture is overall changes in storm track, intensity of storms, those kinds of things we have a better handle on than exact wind speeds. There is large model-to-model variability in the climate change signal. However, models do suggest moderate declines in mean wind speed over the next 50 years of about 3%. So it's not a significant trend overall, but about 3% reduction in our average wind speed is what the models are predicting. So this global image should look familiar. I also pulled this from the IPCC report. So anything in blue is a reduction in wind speed compared to present-day wind conditions. Anything in green is an increase in wind speed. You do see a lot of those diagonal lines here, so there is less confidence in some of the model output, but certain features do stand out. You can see for much of the central U.S., it's about roughly 2 to 3% reduction in average wind speed. You can see the parts of the world where wind speeds will increase. In general, there will likely see a poleward or northward shift in storm tracks. You're seeing greater wind speed in the polar regions and in the Arctic. So certainly in regions like that, there's great potential for wind energy production. Some other implications to consider, along with a change in wind speeds, thinking about the atmosphere is going to be warmer, more extreme events. In terms of the operation of wind turbines themselves, what sort of implications might we expect? Climate change may alter not only the wind resource, but the environmental context, operation, maintenance, and design. So thinking about that aspect of wind energy production. Wind's extreme speeds and gusts, given that we'll have more extreme events. So if I was an operator of a wind turbine facility and thinking about its operations, I would make sure that there would be capacity and the design could handle greater wind speeds and greater variability in wind speeds. Icing events, this could depend on where this wind energy is deployed, but there could be greater frequency for ice events and shedding of ice events off of the turbine blades. That would be something to prepare for. The different operating temperature and air density. So a warmer air, if your air temperature goes up, the density of the air actually goes down. It's just kind of simple physics. So thinking about the blades themselves and the production of that wind turbine just based on an increased air temperature and a reduction in wind density, that's also going to influence your operations. All right, and then solar. So the statistic that I have here, it's thought that given that our precipitation will likely increase, that will likely lead to a reduction in solar radiation by about 10%. So kind of similar to the wind, we saw a few percent reduction. Solar, for this part of the globe, will probably see about a 10% reduction overall in the amount of sunlight that we're getting compared to what it is now. There is variability, and there will continue to be variability associated with global dimming and brightening, and that's essentially due to what's the composition of the atmosphere. Do we have a lot of particles and aerosols? Do we have smoke in the atmosphere? The picture that you see here, wildfire activity, that's something that's likely to amplify and increase. If we have lots of smoky days, that definitely reduces our incoming solar radiation, reduces our air temperature, and so forth. So these are shorter-term things that would influence potentially solar in terms of a renewable. All right. I skipped a slide there. So I just, John had asked me to talk briefly on the February event that we experienced, and clearly there were significant implications to the energy sector, both in terms of demand and availability. From a climatologist perspective, this is a recent trend that we're seeing. The image that you see there is how that you can see the blue in the middle part of the country. That's the area, the spatial scale that this Arctic era outbreak covered. I mentioned earlier that February's we've seen a cooling trend. This is an implication of climate change because the Arctic is warming a lot faster than the rest of the globe. The jet stream gets more wavy, and we get more polar and Arctic air outbreaks. So this is not a disconnect in climate change. Thank you. This is actually the climate system responding to this overall warming that we've experienced. So in February, we see this cooling trend. So it would not be out of the question if we would experience something like February of this year. I'm not saying that they'll happen every year, but there is potential in the near term for these more frequent Arctic air outbreaks. So that map that you see here, that should be, people should be thinking in terms of there's the possibility of these severe events happening at this time of year. Oops. Another consideration that I just wanted to highlight, and that is, I mentioned that things are warmer, summers are going to be warmer, energy demand during summer, when people are wanting to cool their buildings, they're wanting to irrigate, and that takes energy. So cooling degree days, that's one metric that is output by these climate models. That's the map that you see here. So mid-century, they're predicting about an increase in 325 units, roughly, of cooling degree days. So thinking about what's the energy capacity and demand that we're preparing for, in the summertime, it's going to be greater overall because we're going to be warmer, and it's also going to be drier that time of year. So water usage and requirements and the power that's needed for water usage all goes into play here. So just some considerations here. I'll end up. So the lifetime for solar panels for wind turbines, right? There's an end of life for these. It's a few decades or so in length. So what do we do with all this infrastructure and equipment once it's reached end of life? So thinking, and I don't know the answer to this, but I'm saying that this should be a consideration. We don't want turbines piled up in a landfill. We don't want to cause problems at the end of life for these renewable energies. So just something to think about. This is an opportunity for an industry to recycle or develop something based off of these components. Finally, just to finish up here, so global scale deployment of non-fossil sources must occur soon. From a climatologist perspective, we have to stay off of that that red curve. We cannot have business as usual. Nebraska, when my kids are 7 and 9 right now, Nebraska will not look like it does today if we stay business as usual. It will not. So I talked mostly about wind and solar. There are clearly other options that I didn't touch on. Microhydro would be one. Spreading out the energy sources that we get so that there isn't a single point of failure, I think would be really valuable to think about. Storage, low-cost storage could definitely play a role if we want to ramp up renewable production in a short amount of time and get ourselves off fossil fuels, then storage definitely plays a role. So again, there's an opportunity. And then finally, to maximize renewable energy benefits, that must occur with reduced energy usage. So thinking in terms of not being as energy intensive as we are right now, that's also part of the solution. And there is my contact information. Again, thank you very much for having me for this conference. I appreciate the opportunity to speak with you.
Thank you, Martha. That was, can you all hear me? Thank you, Martha. That was really informative. I know we just have a couple of minutes here for questions. Anybody in the audience that probably a lot of you want to ask?
Thank you so much for all the work you're doing and for this presentation. Just wanted to bring back to that first graph you showed where you were looking at that red line, and you talked about if nothing is done. I was wondering, is that taking into effect at all current mitigation efforts, like if current mitigation is going the way it's going, or is that sort of like just looking at the trends that have been happening recently? Because I know that most scientists agree that even the current mitigation, probably, we're not where we need to be, but I just wanted to know what that was taking into account in terms of goals that, that people are setting in countries and all of that.
Yeah, that's a great question, and there's talks going on right now at COP26 in Scotland. So if we look at CO2 emissions over the last, say, 5 to 10 years, we're pretty much on track for that business as usual. So I would say it does not take into account actions within the next, 5 to 10 years or so. That's what it doesn't take into account. We've got about 1.5 degrees centigrade that's already baked in. So no matter how significant our reductions are, that's going to happen just given the lifetime of CO2, which is about 100 years in the atmosphere. But it's something that should be revisited because it is a moving target. Yeah.
You said that you give these talks around the state and that you have counterparts around the United States doing the same thing. How are your talks received?
It depends on the audience. So I'll put into 2 basic categories in Nebraska. There's kind of the action now. What do we do to make this happen? Give us the scientific information to make decisions, kind of that group. And to those groups, they tend to ask questions about how do I communicate to people on climate change? How do I reach people on this? And then I have the audiences that are skeptical about it. And there may be some of you in here in that category. And so what I try and do there is just localize it and find out what their concerns are and connect the dots with climate to whatever, is it health, is it energy, is it water resources, what sector is of interest to them, and let's connect the dots to climate and figure out a way to talk about it in a meaningful way. So it depends on who I'm speaking with.
The current conferences in Scotland that are going on, what is being discussed in regards to developing nations that are rapidly growing? And I saw something recently about certain countries in Africa discussing that they should have economic freedom, just like the West did when it was growing so rapidly in the 1900s, and we shouldn't hinder their exploration into oil and gas. How are we helping those countries make these climate decisions? Because this is a global issue. What are the conversations like in Scotland regarding that?
Yeah, that's a good question. So they're not finished yet. So I think they last through this week. And from what I've heard, it's, you have countries like China, who the president is not there, although he is sending an envoy. And, they're one of the highest emitters if you look just at total emissions. And then you have some countries, there are some island nations that are not there because they cannot get there for whatever reason. And so you do have, one issue would be having all of these people there at the table, and I don't think that's the case this year. It is certainly an issue. I do feel that it should be a conversation between developing nations and those that are developing, and to try and improve quality of life so that we can lift up those other nations. So I do think it's important. I haven't heard a whole lot yet in terms of what's coming out of Scotland, but I do know that not everybody is represented at the table, unfortunately.
Can you talk about the impacts of climate change right now in the U.S. as well as globally? Like, what's actually happening? What do we see right now?
Yeah. So I'll localize it to, I don't know if you're from Nebraska, but I'll localize it to here. We see heavy precipitation events. So during the summer, we see flash flooding events that causes impacts or erodes fields or takes out roads and so forth. We see heat events and not only daytime high temperatures, but nighttime low temperatures, and the inability to stay cool at night. And that could apply for if you're an animal or if you're a person. An issue I think that's also important to look at is the fact that climate change is disproportional, and so it's impacting certain communities more than others, those without the capacity and resources to deal with some of these impacts. It's shifting planting zones, what you can produce in certain areas. That's shifting northward overall. We see shifts in the time of year that we get snow, for example. I mentioned snowpack in the Rocky Mountains, how that is changing. The businesses that rely on a snowpack, those are being impacted because it's not occurring when it should. Wildfires would be another one, all the health implications with wildfire activity. Hurricane activity, that's another one that doesn't affect us per se in Nebraska, but coastal communities certainly. Insurance rates and so forth, what we can be insured for, those costs are going up. So it really touches so many different aspects.
I had a question over here. I'm sure your slide with the 3% reduction in wind speeds caught a lot of people's attention. Is there information that's attributing to that? I know the models predicted it. Is it related to the weakening jet stream and the migration north, or other causes?
Yeah, so I'm going to go back to this one. So in general, you see kind of the coastal, kind of a northward shift in the storm track. So that's one thing that's attributing to it. And over kind of a calming, per se, reduction in wind speed primarily over the continents, whereas over the ocean you see kind of an amplification in wind speed. So in general, just a restructuring of atmospheric circulation patterns is what is driving this. The thing that drives wind is temperature gradients, and the temperature gradients are getting all different than what they used to be because the Earth is warming up and the Arctic is warming much faster. So the thing that is driving our wind speeds, that is shifting.
Thank you for your presentation. I'm wondering if you could put the United States carbon emissions into a global context, because I often hear folks say, well, why should the United States take action if we have China as the #1 global emitter, if we have India, and, as was mentioned earlier, many developing countries increasing carbon emissions. So could you just put the U.S. into that greater context?
Yeah, so in terms of volume of emissions. The U.S. ranks third, but where there's a disconnect is the U.S. is, on a per-person basis, the U.S. is by far, we're way out on the spectrum compared to all other countries in the world. So on a per-person basis, that's where the U.S., that's where there's a very significant disconnect, which is really more meaningful, I think, than total emissions, because it's based on population and industries, of course, but on a per-person basis, the U.S. is much higher than any other country in the world.